We are now in section 9.2, which is arithmetic sequence. So the main feature of an arithmetic sequence is this thing called a common difference. Basically, if you subtract consecutive terms, you should get the same value. It's very similar to a slope in that it's a constant rate of change. So we're going to try this example. Show that the sequence is arithmetic. Find the common difference D. So one way we could do this is by listing out the first few terms and see if we notice a common difference between them. So let's find the first term, t sub 1. So it's 2/3 plus 1/4. Normally I would find a common denominator and add those together, but for this example I think it might be easier to see the common difference if we leave it like that. So t sub 2 will be 2/3 plus 2/4, which I'm not going to reduce because I'm looking for this common difference. T sub 3 is 2/3 plus 3/4. So hopefully you're kind of noticing here that they all have 2/3, but we're adding higher and higher fractions, 1/4, 2/4, 3/4. So what I'm noticing is that the common difference would be I'm adding 1/4 each time. So if I subtracted consecutive terms, I would get 1/4. So the common difference would be 1/4. Let's try the next one as well. Find the nth term of the arithmetic sequence given a1 equals 0 and d equals pi. What is the 51st term? Okay, well, let's try listing out the first few terms and see if we notice any sort of pattern. So a sub 1 is given. It is 0. Now, the way to get the second term is to take the previous term and add the common difference. So the second term is pi. So the way we would get the third term is take the previous term and add the common difference. So a sub 3 is 2 pi. And then the way to get the fourth term would be to take the previous term and add the common difference, 3 pi. So the terms are 0 pi, 2 pi, 3 pi. So what it looks like is we could find the 51st term by just subtracting by 1 and multiplying by pi. This seems to be the pattern that we have in these first four terms. Another way to express an arithmetic sequence is with this formula here. This is kind of the standard formula for the nth term of an arithmetic sequence. So notice you need to know the first term and you need the common difference to create this. So we can use this for the next example. Find the 80th term of -1, 1, 3. So in order to apply the nth term formula, we need to, first of all, note the first term, which is -1. Now we also need to find the common difference. So it looks like from term to term, we're adding 2 every time. Okay, so that would mean that D is 2. So now let's create the formula for the nth term. So with the first term plus n minus 1 times the common difference. Now we can use this to find the 80th term. So a sub 80 is -1 plus 80 minus 1 times 2, which I'm going to put in my calculator. So -1 plus 80 minus 1 times 2. So it's 157. So it's kind of a quicker, easier way to find any term of the arithmetic sequence is by having the formula for the nth term explicitly written. So this example is asking us to find the first term and common difference of the arithmetic sequence, give a recursive formula, and find a formula for the nth term. The 12th term is 4 and the 18th term is 28. So first I'm just going to reiterate the formula for the nth term. So they've given us pretty much 2 terms here. They're saying that a sub 12 is 4 and a sub 18 is 28. So what I can do is I can plug those into this general form and create a 2 by 2 system of equations, which I need because I am trying to find 2 unknowns. So let's go ahead and do that. So I'm going to use the fact that a sub 12 is 4 And I'm going to replace a sub n with a sub 12 and replace n with 12. So this will be 11d because I'm doing n minus 1, and here is 12. Same for this one, a sub 18 is 28. So n is 18, so this is 17d. Okay, so I need to solve this 2 by 2 system. I can use substitution or elimination. I think I'll do elimination. I'm going to multiply the top equation by -1 and write it below, so I can add the two equations together, and that way I can eliminate a sub 1. So when I add these together, I get 24 equals 6d. I eliminated the a sub 1 term here. So divide by 6, so the common difference is 4. Okay, now I can take that and plug it back into either equation for d to find a sub 1, the first term. So I'll just use the top equation. So 4 equals a sub 1 plus 11 times 4. So 4 equals a sub 1 plus 44. Then subtract 44 from both sides. So -40 equals a sub 1. So now I have enough information to write out not only the formula for the nth term, but also the recursive formula. So the formula for the nth term, a sub n, would be equal to the first term plus n minus 1 times the common difference, which was 4. So this is the formula for the nth term. The recursive definition, we would first need to give the first term. So a sub 1 equals -40. Then we can divide the nth term by the n minus first term. So it will be n minus 1 plus the common difference, 4. So this is just two different ways of expressing the same arithmetic sequence. Next, we're going to look at adding up the terms of an arithmetic sequence. Luckily, there's a shortcut for that. If you're finding s sub n, which is the sum of the first n terms, you can apply this formula. So in order to apply the formula, you need to know the first term and the nth term, okay? But it's pretty quick and easy. It's certainly much easier than listing out all the terms and trying to add them together. So let's try this first example. You can see the terms are listed out. It's not in summation notation. So we can easily note that the first term is 8. And then we have the last term, which is 50. But the question is, what is this n? We need that for the formula. You'll see in the fraction right here. We need to know how many terms we're adding up. What is that last term? Well, we can solve for that n if we use the formula for the nth term of an arithmetic sequence. Because we know a sub n is 50. We know the first term is 8. Of course, we don't know the n value corresponding to 50. And the common difference, well, let's take a look at the terms. 8, 8 1/4, 8 1/2, 8 3/4. It looks like 1/4 is being added each time, so the common difference is 1/4. So we can take this equation and solve for n to find out which term is 50. Right? How many terms exactly are we adding up? What is n? So I can subtract 8 from both sides. I'm going to go ahead and multiply by 4 to get rid of this fraction. So this will be 168. And lastly, add 1. So what this has told me is, oops, I meant to write n. There we go. So what this has told me is that 50 is actually the 169th term of this sequence. So now I can write out that I'm finding the sum of the first 169 terms. So that'll be 169 over 2 times the first term, 8, plus the last term, which is 50. Okay, I'm going to type this into my calculator. 169 divided by 2 times 8 plus 50. So the sum is 4,901. Okay, this one we actually have it in summation notation, so we know that we're adding up the first 80 terms. Actually, there's a typo here, so I want to adjust that for you. This should be a K, right? That's the index. Okay, so let's go ahead and write out our formula. So we're adding up the first 80 terms. So it's going to be 80 divided by 2 times, now we need the first term, so let's find the first term. So it's 1/3 times 1 plus 1/2. So if we find a common denominator, that would be 2/6 plus 3/6, so 5/6. Plus, now we also need to find the 80th term. So that would be a sub 80. 1/3 times 80 plus 1/2. So that would be 80/3 plus 1/2. Not as easy to do in our head. Let's get the common denominator at 6. So this would be 160 over 6 plus 3 over 6. So that would be 163 over 6. Okay, so let's write it in. This, I think I'll just put this in my calculator. So I have 80 over 2, which is 40, times 5/6 plus 163/6. Okay, so I got 1120. 1,120 is the sum. So this next example is saying find x so that 2x, 3x plus 2, and 5x plus 3 are consecutive terms of an arithmetic sequence. So we're given 3 terms, all in terms of x, and we're told that they are part of an arithmetic sequence. So we can use the fact that terms have a common difference to set up an equation. Basically, if I subtract consecutive terms, I should get the same number every time. So if I subtract these two, 3x plus 2 minus 2x, I should get the same thing as if I subtracted these two, 5x plus 3 minus 3x plus 2. So I'm just using the fact that consecutive terms have a common difference. So let's solve this equation. So this is 3x minus 2x is x, 5x minus 3x is 2x, 3 minus 2 is 1. Subtract x from both sides, and then subtract 1. So x is equal to 1. So that is the answer. It's asking us to find x, but let's kind of investigate what this means in terms of the arithmetic sequence that's listed. So the first term was 2 times 1, so 2. The second term was 3 times 1 plus 2, so 5. And the third term was 5 times 1 plus 3, so 8. So it looks like it makes sense. The consecutive terms would have been 2, 5, 8. And they do have a common difference, which is 3. So it checks out. And let's try one more example for this section. How many rows are in the corner section of a stadium containing 2,040 seats if the first row has 10 seats and each successive row has 4 additional seats? So in order to answer this question, we're going to have to combine a couple of formulas that we've already looked at. We're going to need the formula for the nth term of an arithmetic sequence. This will tell us how many seats are in a single row of the section. We'll also need the formula for the sum. So I'm going to write these down so we can use them to answer this question. So it says the first row has 10 seats. That's pretty much telling us that a sub 1 is 10. And it's saying that each row behind that row has 4 more seats as you go back. So that's giving us our common difference, which is 4. So we've already been able to set up a formula for the nth term, meaning how many seats are in any given row of this section. We've also been given a sum. In total, there are 2,040 seats. So I can apply this formula by saying, okay, this is 2,040, so 2,040 equals, now the thing is I don't know n. I don't know how many seats there are. I'm sorry, I don't know how many rows there are. So I'm going to leave that as n over 2. Times a sub 1 plus a sub n. Well, a sub 1 we know. We know that the first term of the sequence is 10. Now a sub n, we don't know what it is as far as what number it is, but we do have a formula for it. So I'm going to replace that with the formula. So I'm just literally taking what I have here and replacing it in this formula for s sub n. So by doing that, I've created an equation which I can now solve for n. So I think the first thing I'll do to solve this is multiply both sides by 2 to get rid of the fraction. And then let's go ahead and clean up the inside of the parentheses. I have some terms I can combine. I can distribute the 4. All right, keep going. So I have n times 4n plus 16. And then I can distribute the n. 4n squared plus 16n. Noticing that all these terms are divisible by 4. So I'm going to divide both sides of the equation by 4 just to make the numbers smaller. So I divided both sides of the equation by 4. It's a quadratic equation. If I move the 1020 over, it might be factorable, but these numbers are pretty, or at least the 1020 is pretty big, so I'm not going to bank on my factoring ability on this one. I think I'll complete the square. B over 2 squared is 4. That's a pretty nice number to add. So I think completing the square will work nicely. If you hate completing the square, you can always do the quadratic formula. So this will factor to n plus 2 squared equals 1024. I think that has a square root. It should. The answer should be a whole number. The square root of 1024 is 32. Great. So I'm going to square root both sides, and I get n plus 2 equals plus or minus 32. And then subtract 2. So this equation has two solutions. N equals negative 2 plus 32, and n equals negative 2 minus 32. The equation has two solutions, but the problem does not have two answers. N is meant to represent the number of rows. The number of rows is not going to be negative 34 rows, so we'll go ahead and cross that one off. So this is n equals 30. So there are 30 rows in the corner section of this stadium.